gonna be copies what we already did. I looked into the next chapter 5. That's into rail cars and stuff like that again, so we should be able to make a little time up on these chapters maybe. Anyway, we're gonna be talking about gases. Gases are materials that are in gaseous state at normal temperatures and pressures. Gases are transported and stored in pressure containers or cryogenic containers. And gases are class 2. See the 2's at the bottom? They're all in class 2 gases. Okay? The gas division numbers are assigned according to the type of potential hazard gases posed, such as flammable. Some of the potential hazards of gas include energy, toxicity, and being corrosive. Other hazards include heat hazards, fire, associated with division 2.1 and oxygen. Gases can travel great distance to ignition sources. Asphyxiation, hazards, leaking released gases displace oxygen in confined space. Cold hazards, that's your cryogenics. Mechanical hazards, your boiling liquid expanding vapor explosion for containers exposed to heat or flame. Chemical hazards, we can either be toxic or corrosive gases. And those are usually with division 2.3. There are multiple class 2 divisions and placards. We can see we got flammable, we got non-flammable, we got inhalation hazards, and we got oxidizers, oxygen. Flammable liquids. Flammable and combustible liquids ignite and burn with relative ease. Most hazmat incidents, such as gasoline and diesel fuel spills, involve this hazard class. In addition to burning, all flammable and combustible liquids exert varying degrees of toxicity. Some flammable liquids are also corrosive. In most conditions, class 3 materials will give off flammable vapors that behave much like gases. Primary hazards of flammable and combustible liquids are energy, corrosion, and toxicity. Primary hazards of flammable and combustible liquids. We have our thermal hazards, that's our fire and vapor explosions. Asphyxiation, it's heavier than air vapors, that's going to be displacing the oxygen, low-lying areas, confined space. Chemical hazards, it can be toxic, corrosive, and these might be produced by the fire Mechanical hazards, that would be your blevy. Vapors can mix with air, travel a great distance to ignition sources. Environmental hazards. When we start talking about environmental hazards, we cause that by the runoff from the fire control. Like I said there Thursday, sometimes if you go to an elevator and they have a fertilizer house, they'll have that posted just to let it burn, don't put any water on it. Because when we mix water with it, we make more of a hazard than if we just let it burn. So that's just some of the environmental stuff. Flammability is a primary hazard, class 3 materials. That would not be a good day.
They just had that down in Houston,
Is that why the gas is going up?
probably.
They burned it all up down there, right?
They had 2 big refineries on fire about a month ago.
Yeah, that looks like a big old tank, let me tell
What's
you.
that? No. I don't think we have any in Houston.
This is just some of the class 3 divisions and placards. We have multiples, flammability, gasoline, combustible, fuel oil. Uh-oh.
The remote getting bored too?
I think it is.
What kind of batteries you need?
Whatever you need, we're out.
Shut it down.
Nicole run to Walmart.
Those triples?
How about the ball marks?
Yes.
You should be able to use
The
your,
triples.
should be able to use your arrow key there. So type, go right
Or space bar?
or space bar, yeah. Tap the space bar once.
Three long bar.
Here. Okay. See if she finds some. This is class 4 materials divided into 3 divisions. We got flammable solids, spontaneous combustible, and dangerous when wet. This is a good one. It may be difficult for responders to extinguish fires involving class 4 materials. Thank you.
That's $5.
Like that. Alright. Class 4 materials are often solids. Most of the time they might be metals. They react violently in unexpected ways. Some flammable solids will react to friction. We have spontaneous combustion materials that ignite with contact with air. Dangerous when wet. If it's involved in a fire, it may burn more intense. They had some of this going out in California for a while. They were burning up warehouses on the where they unload ships. They'd go down and spray water on them, and it would get real intense. And they finally found out somebody was lighting these arson fires with rocket fuel. And when they would get water on it, it would be enough. It was they didn't want the wet stuff on there, and it would get real violent and real hot and bright. Okay, react violently with water. Class 4 fires, materials difficult to extinguish. So involving these materials can be difficult to manage. Even more experienced responders may not fully understand the hazard or the typical response. Okay? Primary hazards, class 4 materials, chemical energy, mechanical energy, corrosive toxicity. We could end up with thermal hazards, which could be hot, heat, fires that start and reignite spontaneous in contact with air or water, fire or vapor explosions, molten substances, chemical hazards from irritating, corrosive, highly toxic gas, vapor produced by fire. End up with severe chemical burns. There again, the mechanical part would be a levy. The chemical hazard from this, production of hydrogen gas from the contact with the metal, production of corrosive solutions in contact with the water, production of flammable gas in contact with the water. And then of course we end up with the environmental runoff that causes a lot of pollution. There's your multiple class 4 divisions. Class 5, gonna be oxidizers or organic peroxides. That's what they're divided into, 2 divisions. Oxidizers, they support combustion, may be explosive. When combined with a fuel, they may burn continuously. Some oxidizers in conjunction with a fuel have the ability to burn continuously without any air being present. Oxidizers may also explode. Organic peroxides are oxidizers with a specific chemical composition that makes them prone to reactivity. When these materials are involved in an incident, you will need a small amount of heat to start the fire or explosion. Organic peroxides are both a fuel and an oxidizer. Because of this, they're reactive. Okay, the primary hazards in class 5 materials: thermal, mechanical, chemical. Thermal hazards from fires that may explode or burn hot and fast. Explosive reactions to contact with hydrocarbons. Mechanical hazards, violent reactions, explosions, sensitive to heat, friction, shock. Chemical hazards, toxic gas, vapors, dust. Asphyxiation hazards from accumulation of toxic fumes and dust in confined spaces. There again's your class 5. Class 6 is poisons, infectious substances, poisonous materials are known to be toxic to humans. Avoid contact with these materials. Inhalation hazards are toxic vapors that can be lethal if inhaled. Some of these materials can be extremely dangerous. Can you see a number on those, see what it is? Because they can travel great distance and kill or harm anyone who breathes them. we have to be real careful with them. Infectious substance, biohazardous materials. They have a potential to cause disease in humans and animals. Biohazardous labels are used for large and small quantities of regulated medical waste. We also have a secondary hazard with class 6. That's your toxic hazards, chemical hazards from toxic and corrosive products, thermal hazards from substance transported in molten form, and thermal hazards from flammability and fires. That do not inhale or come in contact with any secondary hazard of class 6. There's your placards for class 6 and your subdivisions. And these are the two new ones they've added to that: infectious substance and biohazardous. Class 7's your radioactive materials. Class 7 placards and labels can indicate the radioactive materials are present. It's impossible to tell if radiation is involved in an accident, such as a terrorist attack, where no labels or placards are evident. Class 7 placards and labels can indicate that radioactive material are present. You can't tell for sure without specialized monitoring and detection equipment. It is not possible to determine if a container is actually emitting radiation. We have a small package of radioactive materials, must be labeled on 2 opposing sides with a distinctive warning label. Each of the 3 categories bear the unique trefoil symbol of radiation: radioactive white 1, radioactive yellow 2, and radioactive yellow 3. If you see one of these placards, these class 7s, they have to have additional information on there. They have to have the isotope name and the radiation activity. This is some of your common industrial and medical isotopes. They'll be listed. Okay, there's your placards for class 7. Class 8s are corrosives. Either a liquid or a solid that causes full thickness destruction of human skin at the site of contact. Severe corrosion rate on steel and aluminum. Corrosives can also cause a fire or an explosion. They react with metals to form hydrogen gas. Corrosives can be toxic, flammable, reactive, explosive, and some can even act as an oxidizer. Because of the wide variety of hazards presented by corrosives, do not focus solely on the corrosive properties when considering appropriate action. Okay, and if you stop and look at trucks going through here, you'll find corrosives as one of the top ones that come through. Just take a day someday and just watch placards, and just see how many different ones you can see going through your plates, your town. Primary hazards of Class 8 materials: chemical, toxic, thermal, mechanical. Chemical hazards such as chemical burns, toxic hazards due to the exposures, the route of entry into the body. Thermals, we can end up with fires caused by chemical reactions. Here again, we can get levies in on Class 8 too. There's your placard for Class 8. Class 9, miscellaneous. We always have to have one of these.
Just put that down and cover everything.
If you don't know what it is, put that one in there. Is a hazardous substance, or a hazardous waste. It's an elevated temperature material. It also can be a marine pollutant. They'll primarily have thermal chemical hazards. We might end up with elevated temperatures for some of them. We talked about PCBs earlier. That would be one of them in the dangerous goods. Hazardous waste may present any of these hazards associated with materials. There's your dangerous ones, Class 9. Responders should contact additional resources that may provide additional technical information. If you go through the pipeline safety class, they'll tell you what to do with these signs. Usually on these signs, there's a number. It's signs for pipeline. They'll tell you what company it is, what's going through it, and what number to call. And these usually tell where you have to contact them. But that's your additional resources that you need. After you identify the hazardous material, you can use the following sources. This goes back to your ERG. We can use some shippers or shipping papers, safety data sheets if you have them. If you call that number, you can get the pipeline operators. There's those computer apps, Wiser, Cameo. Look at placards and labels. We can even talk to some of the manufacturers to see what we need to do. Some of the other sources that we might get additional information from. We're going to look to see what we need to do for potential health hazards, signs and symptoms of what was exposed, responsible party, who's going to pay for the party. That's the contact information you're going to get. Precaution for safe handling and control measures. What kind of PPE, spill cleanup procedures you got to have, and emergency first aid procedures. We also need to look at the surrounding conditions, survey it. While conducting the survey, first responders should identify relative information, including potential site hazards such as overhead power lines, highway traffic, or rail lines. Most of you guys had rails going through your town? Do you know what time the trains go through?
Night.
Is there particular times?
No.
So does that make it more difficult to do something by the tracks?
Yeah.
How long do they need to stop?
Depends on how long the
Forever.
train is.
Yeah.
At least a couple miles.
I mean, if we're bringing in a unit train or they're taking out a unit train, that's 100 to 150 cars just out of our
Yeah,
plant.
but if they're coming down the tracks, how long does it take them to stop? Takes them at least a mile or two. So you don't just, you gotta get way ahead of them if you need them to stop. That's why we try to make phone calls if we know the dispatch centers. We're also, when we get this, we're gonna look at, see what other hazards we got. Potential ignition sources, potential victims exposures, the weather, the time of day, the topography of the land, information about the buildings, the building components. Hazmat incidents can occur anywhere and often. The location itself will present its own hazard. That would not be a good day there. If an incident occurs on the roadway or highway, the responder will need to take protective actions against traffic and other highway hazards. Falls from overpasses, bridges, other heights, near rail lines, overhead power lines. We gotta be careful of potential contamination to the environment, thermal hazards, potential ignition sources. Yeah, we wanna watch out for one that a lot of people don't seem to think about for an ignition source is static electricity. You'd be surprised how many places you can pick up static electricity. Cigarettes, how many times do you come on a scene where something, fuel's leaking out of a car and somebody's standing over there watching, smoking a cigarette? You know, things like that, we need to watch for that stuff. There's road flares. You know, the state trooper, they were always used to be good at throwing road flares down to get you to go in a certain direction. We're kind of way away from that now, and I'm glad of it, because you could always tell where the fuel was once they threw those down, because it was all burning, so. Make sure that there's no electrical sources there either. Make sure that if that car is upside down, or that truck's upside down, or whatever, make sure it's not on top of a terminal box, or a transformer, or something like that, that could be charging that car up, okay? There's things like that you really need. Make sure, watch out for heat caused by frictions or chemical reactions. Okay, pilot lights, cutting or welding operations. Cell phones. How many of your radios are intrinsically safe?
Should be all of them.
Ours are, and it's a special, you have to order them special. Our pagers are. Cell phones usually stay in the truck. So, that's something to think about. We talked about that. This is some of the actions for flammable and explosive atmospheres. Flashlights, turning them on and off. Activating your cell phone. Turning on and off light switches. You know, you go knock on the door, tell people to evacuate, the first thing you do is turn the light on. Or how many guys go out and ring the doorbell to tell them they have to evacuate because it's flammable. Okay, you just push the button, you just set it off if it's there. How many talk on their cell phone while they're filling their car up with gas? You know, it's things we gotta take into consideration here.
Even getting out of a vehicle with cloth seats can spread
Static.
static.
That's probably more dangerous.
Yeah. And I don't know, I get in the habit, every time I slide out of the car, I go over and I touch the bumper first, the bumper for the pumps. Cause that goes right to ground, get rid of that discharge. Then you're not getting it over by the fumes. Yeah, it depends on the clothes you wear, the more static you get.
End time of season and lots of factors.
Yep, so you just gotta be careful, keep those ignition sources down. Potential exposures, we could have people, property, the environment. Weather can dramatically affect how the outdoor incident progresses or is mitigated. Temperatures are below freezing, it may be impractical or impossible to use water for decontamination. You imagine stripping somebody down and hitting them with cold water when it's below 32?
Fun.
It's better than what's on you.
Yeah, sometimes. Hot temperatures cause the liquids to evaporate more rapidly, producing more vapors. Wind direction. God only know we live in Iowa, we have wind most of the time. Rain, high humidity. Water reactive materials to burn or explode. Time of day can influence chemical behavior. At night, the winds tend to be lighter. Gases and vapors will not typically travel as far, tend to be cooler, so liquids tend not to evaporate so rapidly. Topography makes a significant difference in the consideration needed to determine the appropriate isolation distance. Remember, if we got hills going down, stuff's gonna go down the hills probably faster. Okay? Depends on what state they're in. Topography is a factor in rural environments such as flat plains or passes through mountains. Topography will play an important role in where liquid and gaseous hazard materials travel. Some of this stuff, if it's liquid, it'll start going towards storm sewers, drains, which ends up in streams and rivers, leads to ponds and lakes. So we want to keep that, we don't want that stuff in our waterways and just environmentally sensitive areas. We need to take care of them. It does the same thing with vapors. We get the winds, we get the upslope winds, downslope winds. Okay. Building information, if we have something happening inside a building, location of the floor drains, air handling ducts, returns and units, location and components of fire protection and detection systems, location of gas, electric and water shutoffs, presence of potential backup generators, emergency response centers. ERG provides contact information for those in the United States, Canada, some of those other places. Those will be in the white pages in the front of the ERG and on the back. I don't have any phone numbers on the back anymore.
They're on the back page.
Back page? Yes, they are. There's a ton of them. Just in case you're in Columbia, you can call it in. Okay, if you got that drug shipment that's got delayed, you can call down there. Alright.
Disciplinary and hires.
Yeah, that's what they had hired. Okay, Chemtrek, that's the number you can call. They'll get you to the right people, there's somebody there 24 hours a day. Transport, Canada's got a number, Mexico's got a number. If you're gonna call one of these things, we have to have some information. The response centers will need it. The caller's name, callback number. And like I said, that callback number is real important because when I called Sioux City, they gave them the wrong number to call me back. The comm center did. Or they wrote it down, I should say, somebody wrote the number down wrong. Anyway, so they had a hard time calling me back. So we need to make sure that's correct. We need the location, the nature of the problem. Is it a spill or is it a fire? Name and identification number of the materials involved. Shipper, point of origin, carrier's name, rail car, if it's got numbers or letters on it. Container type or size, quantity of the material. What's your local conditions? Is it, you know, you want in your local conditions, you want to tell them what the weather is, what the terrain's like. Are we close to schools? Are we close to hospitals? Things like that. Are we close to a waterway? That's things they need for local conditions. Injuries, exposures, involving spills, leaks, fire explosions, vapor clouds. Local emergency services that have been notified, they need to know all of that. Emergency Response Center will do the following: confirm that a chemical emergency exists, record details electronically and in written form, provide immediate technical assistance to the caller, contact the shipper, provide the shipper manufacturer with the caller's name and callback number. Guess what?
Yay.
Yippee skippy, we're done with 4.